Welcome to the introduction to ratios. You probably know this already, but I will cover it just in case you missed out somewhere. The objective here is to get a feel for ratios. Look at the picture that's sliding in. It has 5 bottles of water and 1 bottle of orange squash. When you mix 5 parts of water to 1 part of orange squash, you get a refreshing drink. Maybe. In other words, we use a ratio of 5 to 1. In the next few slides, we will look at 3 situations that can be described with ratios. Here is a picture of a school. There are 30 students to 1 teacher. It's not easy for teachers or the students. And we say it has a ratio of 30 to 1. There are millions of ratios. Almost anything you can think of has a ratio. You may be surprised to learn that playing computer games have many ratios. When you set up your TV or your computer screen, you can change the aspect ratio, that is, the ratio between the width and the height. Here is a cartoon that says, you have to rise before you can run. That might help you remember the slope of a line is rise over run. The slope of a line is also a ratio. I have included the graph from the numbers line, just as a reminder. In this case, rise over run is 5 over 10, which reduces to 1/2. Another way to describe ratios is to say it compares numbers. We use the colon to separate the two numbers. Here we see the ratio of 3 to 1. We can scale this ratio up by, say, 2, making it 6 to 2. We can scale ratios by any useful number. That number is called a scalar. Isn't that obvious? I'd like to mention some other ratios. They come under different names, but they are still closely related to ratios. We have trigonometric ratios. The tangent ratio is the same as the rise over run. Vectors represent ratios are used to represent items that have a quantity and a direction. However, they are very closely related to ratios. Equations of a straight line is an extension to that of rise over run. Pythagoras' theorem relates the rise over run to the length of the hypotenuse. Even when dealing with curves, the gradient of a curve at some point that you choose becomes a ratio or a slope. Even differential calculus is a quick way to find a new formula that will tell you the slope of a line at some point on a curve. There's no need to remember this. It's just to give you a feeling of what ratios are and where they are likely to lead.